Hey everyone, in this video I wanted to talk about bow tie triangles as well as revisiting overlapping triangles concepts. I call them bow tie triangles because you kind of see that it looks like a little bow tie. They're just similar triangles that meet at that common vertex point, this one being point E here. So always read the similarity statement that goes along with it because it'll tell you a lot of information about this problem. So we're told that triangle ABE is similar to triangle CDE. So all of their corresponding angles are congruent and all the corresponding sides are proportional. So the first thing I'm going to do is mark all of my congruent angles with angle markings. That means the little swoosh marks that we've seen. So angle A is congruent to angle C, like we see here. Then I've got B to D, so B to D, I'm going to use two swooshes on that one. And then for the last angle, this one in the middle here, I don't just want to say angle E and angle E. I'm instead going to say that it's angle A, E, B to angle C, E, D. So I'm using 3 points to name that one specifically. So filling in these blanks, just like we talked about, we had angle A is congruent to angle C, angle B was congruent to angle D, and then that last one, AEB, is congruent to angle CED. And I want to make sure I go in that specific order when I'm naming it because it's going in the same order using the similarity statement as well. If I go A to E to B, I want to do the same thing, C to E to D. So now let's talk about the corresponding sides as a proportional side statement. So just like we've looked at before, if I have AB over CD, so using the first two letters there, I can do the same thing with my next two letters, so BE over DE, BE over DE, and then our last one, I would have A to E over C to E, A, E over CE. What this allows me to do is now I can use this corresponding side proportional statement to answer any questions that I might have. So in part C, where it says if AB is 12, BE is 16, AE is 8, and DE is 6, label all the missing side lengths of triangle CDE. So I'm going to label those really quick. 12, 16, 8, and oops, not that one. DE is 6. So I'm going to take this and I'm going to plug in the numbers that I have there. So I've got AB is 12. I don't know CD. I do know BE is 16. And then DE is 6. And I know AE is 8, but I don't know CE. Now to find my missing side lengths, I have to set up two separate problems. I'm not going to use all three of them together, but instead I'm going to take our unknown sides, so the ratio and the unknown, we're using one of the unknown sides with one of the ratios that has each known side there. So for my first one, I have 12 over CD is equal to 16 over 6. So that's 16 times CD is equal to 72. And then if I divide by 16, CD is equal to 4.5. Same thing, 16 over 6 is equal to 8 over CE. So that's 16 times CE is equal to 48. So CE is equal to 3. So those are my missing sides. Now the ratio of our corresponding sides of the larger triangle to the smaller triangle, well, let's look at that. So if I'm going to erase this, let's say I take all of my side lengths and I'll put them into their corresponding side ratios. So I've got 12 over 4.5, 16 over 6, and 8 over 3. Now the ratio of our corresponding sides, I want to have it as a reduced fraction. And because these sides are proportional to each other, they're all equal ratios. 8 over 3 is the reduced fraction. I can also say, well, 16 over 6 would also be 8 over 3. And then 12 over 4.5 is also 8 over 3 as well, if I were to reduce that in my calculator, if I did some math there. So my ratio of our larger triangle to the smaller one is 8 over 3, or 8 to 3. Revisiting our overlapping triangles, like we said in the past, it's similar to if we, like if I remove this line here, I would see one big triangle, and I have this small one on top. I can redraw these if I want to, just to give myself some like visual clarity. So I've got D, B, E, A, B, C. So if I want to create my similarity statement, the first one we're naming is D to B to E. So I want to go that same order for the second one, A, B, C. And we're using the same one for number 2. It's almost the same diagram. It just, I have the same letters in the same place. I just add some units there, as well as changing up some of the angles a little bit, but they are the same triangles, right? So I could redraw them to be the same thing, just like I have over here. So let's go ahead and do that. Right triangle. Here's a bigger one. So I've got D, B, E, A, B, C. Now, when I'm labeling my side lengths, the small one's pretty straightforward. 5, 4, and 3. My bigger one, I have to be careful because the entire side length of A to B is AD and DB together. So that's 12.5. Same thing with BC, the 4 and the 6, giving us a 10 there. So I've got 12.5, 10, and 7.5. Now, identifying the scalar from triangle ABC to triangle DBE, I'm trying to figure out if I'm going from the bigger triangle to the smaller triangle. The scalar is what we are, it's basically our reduced ratio. So I can set up proportions if I want. I've got 12.5 over 5, 7.5 over 3, and 10 over 4. All of these are going to reduce to the same thing, 5 over 2. So there's the quick and easy talking about overlapping triangles and bow tie triangles that we're seeing here. This practice set on the second side of that worksheet, kind of working with some of these similar problems. Be careful. I give the similarity statement for most of these problems, especially with bow tie problems. You don't just want to assume it's always like the side that's directly across from it. That's your corresponding proportion there. Make sure you're reading the similarity statement for each one. As always, email me if you have questions, and I'll see you all in class tomorrow.